All right, so we talked about how to solve force problems, and they're not about to get any more complicated, but you're going to think that they're going to get more complicated. And so here you are in an elevator. Very happy because you love elevators. The elevator is moving up. Is the net force on you up or down? Well, if you watched my last video, hopefully you don't know. There is no relationship between velocity and net force. You don't know the direction you are moving based on the net force, and the direction you are moving has nothing to do with the net force. Remember, net forces don't say anything about velocity or direction. What they say is that when there is a net force, a mass will change its motion. A net force causes a mass to accelerate. So the direction of your velocity is inconsequential. What is important is the direction you are accelerating. Let's say you are accelerating upwards. Well, then the net force on you is up. If your acceleration is up, your net force is up. If your acceleration is down, your net force is down. It's really that simple. Students will get this wrong all of the time. Let's say you are moving down and you are slowing down. What does it mean to slow down? It means to go less fast. If you are not going as fast anymore, then your velocity became smaller. Your velocity was big and now it's small. That means the direction of your acceleration was up. This big arrow plus this little arrow will lead to this black arrow. So even though you were moving down, your acceleration was up because you were slowing down. So you were on the third floor, you're moving to the first floor, and as you get to the first floor, the elevator slows down and comes to a stop. And as that elevator slows down and comes to a stop, your acceleration must be pointed upward and the net force must be upward. You might have noticed that when the elevator comes to a stop at the bottom, you kind of feel a little bit heavier. Or you might have noticed that when the elevator first takes off, if you were on the first floor and you are going to be going to the third floor, you might have noticed that when the elevator first moves, you kind of feel like you're a little bit heavier. You feel the elevator start to push you up. Because when the elevator first starts to move, it must accelerate you up. So we really have to pay attention to what direction we are accelerating, not what direction we are moving. Okay, now, knowing that, let's say we have an elevator problem. And it looks like it's going to be really complicated. And it says something like this. You are standing, oh, whoop, that was silly of me. You are standing on a scale in an elevator. You have a weight of 120 newtons. That is your weight. Currently, the scale reads 150 newtons. What is the magnitude and direction of your acceleration. And now, wow, where do I even start? This seems like a crazy hard problem. Well, we're going to start where we always start. The first thing that we're going to do is we're going to not freak out. We're not going to do anything in our head at all. We're just going to draw a picture. Here you are, standing on a scale. And so, let's draw your free body diagram. Don't you look beautiful as a square? And you have your force of gravity down, aka your weight, and you have your normal force up on you. Whoa, time out. Because the normal force is always pointed up, right? Wrong. Oh, because the normal force is always opposite gravity, right? Wrong. Normal means perpendicular. So the surface is horizontal and the normal force is perpendicular to the surface. So the normal force is pointing up in this scenario. What is the normal force really? The normal force is really just the scale. The scale is providing the normal force. So it's really the force of the scale. So if I were to come over here, I would say this is your Fg, and I would say that this is your Fn. And I have to be very, very, very careful that this is magnitude only. These have no directions right now. So let's go ahead and let's write 150 newtons here, and let's go ahead and write 120 newtons here. What's my acceleration in terms of magnitude and direction? This seems like a very hard problem if I don't take it step by step. The way to approach all these problems is, can I solve for anything? Can I do anything? And if you can, do it. It doesn't matter if it gets you the answer, because it gets you more information. So maybe I will start here. I will decide that up is positive and down is negative, just to follow convention. And as always, I will write F net equals ma. By the way, what I was going to say is if I draw two different axes, a y-axis and an x-axis, again, I'm just doing this for convention, there are no x forces. So if I were splitting this up by x and y, which I should always do, there's nothing to put over here because there are no x forces. So my F net equals ma. And as always, F net is also every single force I see. So I see Fn and I see Fg. And now of these two equations, I'm just going to try to solve stuff. Okay, F net equals Fn plus Fg. So F net equals 150 newtons plus negative 120 newtons. And F net is now 30 newtons. Great, I have figured out that F net is 30 newtons. It came out positive. So that's up. And now that I know that F net is 30 newtons, I'm just going to erase here for the sake of space. I can go back and try to solve this other equation. Uh-oh. I don't know the mass. Shucks, is there any way I can find it? Well, hopefully you have gotten used to the idea that when we are on Earth, we know the acceleration due to gravity, and we know the relationship between something's weight, its mass, and the acceleration due to gravity. So we always have this at our disposal. We know that Fg equals mg. Since I know Fg is 120 newtons, I can solve for the mass, because if you're taking Regents physics, G is on our reference table. If you're taking AP physics, G is on our reference table. If you're just taking physics in general, little g, the acceleration due to gravity, is something that we should know on the Earth. It's about 10. For the purposes of this video, we're just going to call it 10. So now I can solve for my mass. Fg, 120 newtons. Oh, and it's negative because I called down negative. Equals mass times. The acceleration due to gravity will always be towards the Earth. So in this case, it's going to be down. So I will also call it negative. That finds me a mass of 12 kilograms. Great. So I had a way to find this. This is going to be an important concept to remember. Regents physics, AP physics, either of those. That idea is one that you are expected to know and be able to recall frequently. So now I have 30 newtons equals 12 kilograms times A. And if I divide by 12 kilograms, I find 2.5 meters per second squared equals A. And that's a positive, which means it's up. So I am accelerating up at 2.5 meters per second squared. Quick recap. What did I do? I drew a picture. I wrote down F net equals ma, and F net equals all the forces, and then I just solved. That's it. That's all I had to do.